Great. So the question itself seems stupid, right? Is AI ready for the real world? Duh. It's already everywhere, right? Have people seen this? I mean, there's all kinds of medical applications. Of course, that. Well, actually, not. That's not a given anymore, given the age group of the audience, right? Sorry, I don't have a picture from Insta, right? And things like that. Anyway, so apart from that, so you're using AI every day, right? So literally, right? So if you had any questions about it, so Flipkart, Amazon, Google Maps, Alexa, all of these guys use AI a lot, right? It's going everywhere, right? So this is about quotes using this. Is not just all this fancy, equipment. It's not just the Amazons and Googles and Facebooks that use AI, but banks, right? Insurance companies, right? And quotes. Everybody is using AI. In fact, I like this slide. This tells you that's chemistry, that's physics, that's math, and that's biology. Right. So AI has actually enabled to create breakthroughs in all kinds of scientific disciplines also, right? And of course, it's all, this is a joke. So AI is everywhere. It's flipping burgers. They still quite haven't figured out how to do dosas. Right? So you know why? Huh? Alpha biryani. Really? Is there an alpha biryani? No. So Flippy is from a very different company. It's actually old as far as AI technologies goes. It's 5 years old, right? It's not and didn't come from DeepMind. It's actually an Australian company that does this. They still haven't figured out how to do dosas. You know why? Any guesses? It's incredibly hard for robots to handle floppy things. This is the burger holds its shape, right? Dosa is much more malleable, and robots can't handle malleable things. In fact, if you go to many robotics conferences, they'll show you very triumphantly how they have trained a robot to fold a towel. Right? It turns out folding a towel is actually a very hard, it's very challenging thing because it doesn't hold its shape, right? It's not a rigid body, so manipulating those are very hard. So anyway, so the prevalent thinking is all you need to succeed in building an AI application is to get large volumes of data, right? Preferably tagged data, right? And then of course DeepMind guys come and say, no, all you need is some kind of a simulation model. You don't really need that, and then you can build AI that beats the world's best players, right? So you guys know about AlphaGo, right? Because we're talking about Alpha Biryani. So how many of you have seen the AlphaGo documentary? One. Okay. So no, not only is AlphaGo an amazing AI advancement, right? The AlphaGo documentary seems to be amazingly made documentary. I think it has won like 5 or 6 awards in film festivals worldwide in terms of very well made documentary. So even if you are just documentary fans, you should see the AlphaGo documentary. And if you want to know more about AlphaGo, you should certainly see that documentary. It's there on YouTube now, I think, right? Yeah. So the idea here is this game Go, right, is a very challenging game for AI systems to play. So why is it challenging for AI systems to play? So typically AI, classical AI, right? They look at coming to a position and then look at all possible moves you can make, all possible responses your opponents can make, and so on and so forth. That is called like the branching factor of the game, right? And this game has an average branching factor of, chess has an average branching factor of 35. Right? And chess is a well solved game now, right? Computers can play chess well. So what's the average branching factor of Go? Any guesses? 250. Right? So it makes it very hard for classical AI techniques to play Go. So people tried using learning approaches and other things. They were never able to scale quite well, right? So always people used to say, oh, this is like one of the final frontiers for AI. And if AI systems can play Go well, then we know that AI has arrived, right? So then I don't know if I have a picture of David Silver. So there's this guy called David Silver who had been working on this problem for a lot of time from during his PhD, and then later on as part of DeepMind he built this he and his team built this engine called AlphaGo, right? And AlphaGo took on this person Lee Sedol, who is widely regarded as the one of the strongest players of Go in the history of the game. Right? He's supposed to be very good. Right? And so, DeepMind was making all the right humble noises, saying that we hope that we don't embarrass ourselves while playing with Lee Sedol, and we hope we win a few games and things like that, maybe 1 or 2 games and stuff like that. And then it played remarkably well against Lee Sedol, that when they came to the 4th game in the match, they were playing a 5-game match. The 4th game was won by Lee Sedol. That was a huge surprise to people. Not the fact that AlphaGo was winning, because the first 3 games it was playing so well. The fact that Lee Sedol managed to win 1 game against AlphaGo looked very surprising to people, right? And then, of course, it learnt from that mistake and came back and beat him in the 5th game. Right. So later on, when I was talking to people from DeepMind, so David actually told me that that is the only game that AlphaGo has lost to a human. So you can see why Lee Sedol is regarded that highly, right? He is the only person to have won a game against AlphaGo. Amazing, right? So the nice thing about this was it was actually learning to play against itself, right? It learned to play against itself and then came back and played against human beings. So it could, things like this could happen. This is very infamous move 37 that happened in game 2 that nobody understood what it did. It played a move, and everybody thought something had gone wrong, right? It made a mistake, right? It's a very, very strange move, said one commentator. I thought it made a mistake, but Lee Sedol knew something was happening, so he just got up and left the room when the move was made. He wanted to go alone and think about a response, and he took a full 15 minutes to formulate a response and came back and played, and still he ended up losing. But he knew that something had changed tremendously, so it actually made a move that no human could even explain or understand or anything at that point, right? So anyway, going back to what we are talking about, all you need to succeed is large volumes of data, right? And for some problems, you need only a simulation model, right? And there's a lot of investment that goes into building this data sets, right, and generating this data set. Right? So people keep calling data is the new oil, and then somebody went to the extent of saying data is the new water. You can't exist without that, etc., etc. But this is not how we learn, right? We don't learn just from people giving us examples. We have teachers who teach us, right? And we actually learn about principles behind things, right? We are taught how to generalize from this, right? And people don't just show us hundreds of examples and somehow you are expected to intuit what it means, right? So this causes a lot of problems, not some. So this kind of learning from data is all fine when the going is good. That's a person riding on a motorcycle, that's it labeled that, right? And then or 2 dogs playing in the grass and things like that. But sometimes it goes off. The skateboarder does tricks on a ramp, right? But that's not a skateboarder, it's obviously a cyclist, right? And then a little girl in a pink hat is blowing bubbles, right? So you kind of went completely off the rails, right? So you really need to know why you did this, right? And so it's okay if these things are like benign stuff like labeling images and you get a few wrong, but then things can get really hairy, right, when you start making mistakes like this. So I don't know if people read about the story. So there was this black man who was sitting at home watching TV with his family. The cops just broke into his house, dragged him out, threw him on the lawn, arrested him and took him to prison. It turned out that a facial recognition software that was looking at some surveillance video in a shop that got robbed had identified this man as the person who robbed the shop in the video. The cops just went in, even though he was nowhere near the shop and he had a very strong alibi for where he was. They didn't even ask, they just dragged him off to prison. And they took a full 36 hours before they released him, even though they realized that they had made a mistake, right? They just didn't release him for a long time. But the point is, this can cause all kinds of problems, right? And here's another thing. So this was supposed to be a software that can make blurry images look more clear, right? So somebody gives it a blurry image of Obama, it makes him into a white man, right? So these things, right? And so the problem with okay. right? So problem with all this modern day machine learning AI systems, right, is that they learn associations from data, right? Just learn correlations from data, right? But they have no knowledge about the structure of the world, right? Nor of the processes of the world, right? They have no idea, no common sense information, right? Doctor would tell you why something is the reason for a diagnosis, right? He won't say, okay, you have TB because your X-ray looks like another TB patient's X-ray. I mean, that's what the AI basically is doing, right? It's not able to give you an explanation as to why is your X-ray an indication of that you have TB. It can basically tell you, okay, you have an X-ray that looks like the X-ray of 10 other TB people, therefore you have TB. Right? That's not the kind of answers you want, right? So there are a whole bunch of different questions that we have asked. The way AI normally operates, right, is that you have data, right? You have some algorithm that learns from this data, right? And then it spits out some model, right? So that model is able to tell you between, in this case, the triangles and the squares. Okay, it's a model that distinguishes that, and then you directly apply it to whatever applications you have in your mind in the real world. Right? So that's how basically these things work. But this is not quite right, right? The AI is not, the model that you build is always not almost always not ready to be applied in the real world. So let's look at a few things, like what are the problems that we could have in the data side. How many of you have heard of this? There was a period of time when you could go to Google and type in the ugliest, what is the ugliest language in India? It actually used to return this answer, Kannada. Okay, of course, we don't know why. Maybe some disgruntled employee in Google fiddled around with these things, I don't know, but that's what happened. Then Google apologizes for Kannada. It's the ugliest language in India, search result after backlash. But then I think this is the most non-apology of an apology I've ever read, right? Sometimes the way content is described on the internet can yield surprising results to specific queries. What did they say, right? I mean, I can't say this, but they just said star 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 happens, right? That seems to be their explanation, right? Here is another example. So this is from Compass, right? That's a bail decision software called Compass that was being used in some US courts, right? And so it looked at the risk levels of people. So you show him this profile, and then the show Compass this profile, and it says, yeah, he's a low risk of committing a crime again. You can give him a bail. And it said Brisha has a very high risk of committing the crime again. Don't give her a bail, right? And this is basically the history here. So Vernon had 2 armed robberies and 1 attempted armed robbery before, and after you gave him the bail, he went and committed another grand theft. And this girl had 4 juvenile misdemeanors, right? And subsequent offences after she was released, she committed no crimes after that. But the AI system was significantly biased, right, towards saying that African Americans will have higher risk than white people. Right? And these kinds of biases are always coming in. Right? It's not enough that you say, oh no, you just have to go get unbiased data, because unbiased data is very hard to come by. Right? If you go to the courts, right, especially the American courts, and try to find unbiased data with respect to whites and African Americans, right, whites and blacks, you will not get unbiased data. Right? Here is another case. Right? Amazon scraps AI recruiting tool that showed bias against women. Why? Well, Amazon had bias against women in their hiring practices, and the tool was trained on this. So what happened in this case was that the tool ended up amplifying the bias that was there in the data. It is not just a question of the bias in the data being used to train the model, and then a lot of people ask this question. So what if there is a bias in the model? Because humans are also biased, right? So you are replacing a human with this machine, and it's not as if it's going to make any worse decisions than the human, right? But it's a lot more subtle than that, right? The first thing is you are institutionalizing the bias. It's no longer a human's personal bias that is influencing the decision. It's, you have now trained a model and you have told people you can use this model to hire engineers. So you are institutionalizing the bias. You are given the bias sanction, saying that it's okay to be biased. I'm giving you a model to that. So that's a major difference in when the AI system is biased in its decisions versus a human being biased in decision. And the second part of it is it really amplifies the bias effect, right? So maybe there were 15 out of your 15 recruiters, maybe 2 of them were biased. Now what has happened? You have replaced all your 15 recruiters with a one model that is biased. Right? It's going to amplify this throughout the system. Even though the bias could have happened just because there were a few bad apples, if you will, right? Now you are amplifying it and you are making it institutionalized. So these are all the problems. So you can't just say because the data is biased, I'll train a model. It's okay if it has a bias. Right? So you'll have to figure out ways of unbiased decision making, even when your data is biased. Right? And this bias can come in many different ways, right? So it's very hard to watch out for all kinds of bias. So there are techniques where if I tell you a priori, right, hey, you have to make sure that you are not biased with respect to gender. I can probably watch out, right? But maybe the guy who was giving bails just didn't like curly haired people. So there might be a bias against curly haired people in the data. You wouldn't know, right? How are you going to even verify? So when you are blindly relying on this kinds of data correlations to come up with decisions, you have to be very careful, right? So there are a whole bunch of research issues that have to do with fair decision making and the notion of social good and other things, right? And so we have to worry about how do you formalize these notions of fairness and ethics, and also how you would, especially in the context of India, right? So we have to explore what is the difference in notions of fairness and other things between the Western world and India. In fact, there is another project that we are involved with, right, which kind of brings up very interesting questions. So everybody talks about race, right, and gender as axis of fairness. If I ask you to talk about an axis of fairness in India, what is the first thing that pops to your head? No? All of you are neutral. Nobody wants to open their mouth. That's because we are recording, right? Okay. I would have expected something else though. Somebody say caste? Huh? Caste and community, right? So for India, that is a major axis, right? But do we even know in what ways caste discrimination manifests itself? For example, in language use. Let's say Google wants to build an engine. They want to make sure that the kind of queries and language, they don't want to get into this Kannada business again ever, right? So they want to make sure that they don't use any language that is disparaging a particular caste. Nobody has even written down this, right? All of us know when somebody is disparaging another caste. When you listen to it, you would know. But there is no glossary, there is no lexicon, right? How will an AI system protect against these things? Right? So there are very serious questions and things that need a lot of work, a lot of research in this space, right? So this is happening, right? So the next dimension that I want to talk about is understanding the decisions, right? I already told you this, like how AI system will give an explanation. Oh, 10 TB patients had the same X-ray, therefore you have a TB, right? So that's not the kind of thing, right? But so this is a Feynman quote that put up here. If you can't explain something to a first year student, then you haven't really understood it. Right. So my advisor had this thing. So he said, my PhD advisor, he used to say that you are ready to graduate if you can explain your thesis in 30 seconds, 5 minutes and 1 hour. But each of these explanations should be complete and correct, right. Only then you are ready to graduate. So you should be able to explain it to somebody in like 30 seconds as to what is it that you did, right. Then you are ready to graduate. So basically, so that's something like that. So you have to really understand these things. Right? But something like this happens. Self-driving Uber car kills pedestrian in Arizona. Right? How am I going to explain these things? Right? There are a few billion parameter vision models that are driving this car, and I really have to explain to somebody why this car, thought a pedestrian was okay to run over. Tough. Right. So how do we come up with, so we want to figure out how you are going to interpret these black box models, right. And so the whole idea is that we probably need to have a human in the loop to explain these ML systems better, right. So let's look at some work that people have done in explanation. So this is one of the popular visual explanation tools that are out there called GradCam, right. This is the original image, and if you ask it to label it as a dog, then ask it for an explanation, it will give you that, right. And then you ask it to label a cat and ask for an explanation, it will give you that. All of that is fine, right. I need another slide deck, but I don't have it because I am not using my laptop. Fine. Okay, there is this other very famous example where you have a wolf, right, and a husky. These are the two classes that you have to classify. Wolf and a husky. What are huskies? Huskies are these dogs that are used in Alaska, right? They're like up north. So it turns out that most of the husky pictures had snow in the background, right? And so you show a picture and you ask it to explain why you label this a husky, right? Instead of showing the dog and cat like it did here, it actually shows the snow. There is snow in the picture, therefore this is a husky. It completely ignored the animal in the picture, right? It learnt that if there is snow in the picture, it has to be in a husky. If there is no snow in the picture, then it is a wolf, right? So these kinds of explanations are all fine if I am wanting to debug what is going wrong with the system, right. So all this okay for a expert, right. But then you go here and fundus images, you look at some of these fundus images, and then you say that okay, this here all of these patches that are there here, and therefore you have diabetic retinopathy, right. So I will show there are some patches here, some patches here, some patches here, and things like that, right. These regions look exactly like the ones I saw in people with diabetic retinopathy, and therefore you have diabetic retinopathy. Right. Now the doctor comes and says, no, that's not diabetic retinopathy, that's just normal age-related degeneration. Right. And they say, you did not show that to me earlier. It's your fault. Okay. So we are not yet there, right. So the AI won't say all of those things yet. But the point is, these kinds of explanations are not enough to go to a patient with, right. So these are good for the AI designer, for the doctor to figure out, okay, is it doing something reasonable? But I can't just pop up some regions on an image and say, okay, this is why you have diabetic retinopathy. I really need to understand what is the implication of this. I need to have some idea about the process of the disease before I can generate these explanations, right. But then if you are actually using the AI like this, then you really have to wonder if it is your fault, right. It is your fault. If AI goes into deployment and starts giving explanations like this, AI is not at fault, right, it is just a program, and the people who used it that way are at fault, okay. So this is something we have to get you all to say answers to this, right. So that is a school bus, everyone agree? What is that? School bus? So how many of you say it's a school bus? My God, really? 1, 2, 3, 4, really? 5, 6, my God. This picture, I am not asking about this picture, I am asking about this picture. Is that a school bus or not? Still only 4 people think it's a school bus? You don't think it's a school bus, huh? It's a school bus. Put your hand up, man. Ah. Okay, thanks. No, it's not a school bus. According to the AI system, it's an ostrich. No, don't worry about it. Don't, you can't explain it. Okay. So basically, what has happened is this carefully crafted noise, right, has been added to this. Really, as far as we are concerned, we don't see the noise at all in the image, right. This noise has been designed to confuse the neural network into saying that the school bus is an ostrich, right, and more, right. The panda becomes a gibbon, this dog becomes an ostrich, right. So these are basically what are called adversarial inputs, right. Adversarial inputs can make the AI system say something incorrect, right. So whenever you build an AI system, it is not enough for you to test it on, be gentle, right, give you question papers for which you know the answers, kind of a thing, no. So you have to test it to see how robust the systems are, right. So these are all things. Here is another thing. So this is an agent that has learned to play football, right. So playing well. Okay, it's learning to go to the ball and kick it towards the goal and all that, right. Now look at this goalie. Instead of trying to defend the ball, goalie is just lying on the ground and crying or whatever, right. And this guy gets completely confused, doesn't even approach the ball. Right. In one case, it just walks away from the scenario, right. Then another case, it falls down and things like that. So you can, so initially you might have thought that you have trained a system to go and kick the ball towards the goal, but it's completely fragile, right, to things that you don't expect it to be fragile to, right. So you have to be very careful about that. So this training piece, you have to be very, this things like explainability, robustness, and all these model quality related issues that are there. The next thing is about data protection and safety and things like that. So somebody gives you confidential data, right, and you want to make sure that the data stays confidential. But it's quite possible that when you build a model and you are trying to use it in the real world, somebody is able to take away the data, right. So for example, how many of you know about the Netflix challenge? It's fairly dated, as you can see, right. Netflix challenge is fairly old. So how many of you know Netflix? Okay, thanks. Right. I really see there are some very studious kids here in the audience who don't know anything about Netflix. The same guys who don't know anything about Facebook and Instagram, I presume. So that's nice. But anyway, so Netflix had a challenge, right. So Netflix is very proud of its recommendation engine, right. In fact, so much so that my wife complains that when I log in and when she logs in, we see completely disjoint set of movies and TV shows now, right. So it's and so now she has taken to randomly logging in as me, so that she can explore more shows. Because if she logs in as herself, she's not able to see those things. Anyway, the point is they are very proud of their recommendation engine, and they said we really want to improve our recommendation engine, so we'll give you a challenge. So we'll release a lot of data where the username will not be available, right. So but we'll give you some data about what movies they have seen and what is their rating for those movies, etc., etc., etc. And you have to build a recommendation engine that will improve on our recommendation engine by at least 10%. Right, the first entry that comes in with our which is 10% better than our recommendation engine, is the winner. So they announced $1 million back then, right. So that's a lot of money. So people were very thrilled and they were trying to do this, and but it turned out that they thought they had released an anonymized data set. They had released an anonymized data set. They had taken out the names, but what happens is these guys actually started, joining it with other databases. So go to IMDb. So look at how people have rated movies on IMDb, and look at various other kinds of sources like online sources. They started pulling in more and more information, and they were able to quickly identify which person had given the ratings for a good fraction of people in the Netflix data, even though they had released it in an anonymous form. right. So this whole anonymization piece is a little tricky, right. So people have been looking at other ways of handling it, but it's always a challenge. You can never be 100% sure that when you build a model using some data and when you release some of the data, that you are not releasing to the world what you don't intend to. So there's a lot of things that we have to look at, right. So the whole issue of privacy and safety and other things have to play a big role in building these systems. I think I've more or less come to an end. This is about data drift, right. So you build a model, right, and you're trying to use it on the world that looks like this, but over time the world can morph, right. I hope we never start living in a coffee cup, but some days I feel like I'm living on coffee though, right. So we really need to build models that not only look at a data that was given to you, right. So somebody picks a data set, gives it to you, then you start building models on top of it, but that's not enough. So sometimes what happens is, especially in things like that loan decision making I was telling you about. Remember the very first I showed you an example of banks using AI for deciding on loan applications, right. The very fact that you have started using an AI for deciding loan applications and the AI is using certain logic for deciding that will cause the behavior of the people who are applying for loans to change, right. So the very fact that you are deploying an AI system will cause the data itself to change, right. Likewise, if you build an AI system to prevent somebody from launching attacks on your server, right. So the very fact that you have that AI system that is going to make them try new things, right. So your AI will then soon become ineffective, right. So it's not just natural drifts that happen in the data over time. It could be very well that the data, the deployment of your system itself will cause this data changes. So you'll have to worry about all of this, right. So other, of course, is AI ready for the real world? And so where is the real world nowadays? Yeah, your real world is here, right. So you have to make sure that so you are able to implement all of these on the edge, and that itself is a huge problem. So quite often what happens is people treat all of these issues as orthogonal, right. I might build a very fair and secure AI systems as long as it's running on the cloud. As soon as I make some changes to make it run on the edge, some of the guarantees that I had might vanish, right. So whether the AI system that is running on the edge has the same fairness guarantees, right. So as long as I'm testing it on the cloud, it doesn't send black people to jail. As soon as I put it on the phone, it starts sending them to jail, right. So it turns out that as stupid as it sounds, that's been known to happen, right. That when people build systems, so the different team that is actually looking at taking a system and making it run on the edge, and a different team that is looking at making systems fair, right, and they might not talk to each other, right. So way forward, AI is really successful, right. They now in a lot of domains, right. But the current AI systems understanding of the world, I would say, is about the level of a 2-year-old, right. It really doesn't understand the world, right. It's really in a monkey see, monkey do kind of a stage of mental development now, right. It's a long way to human-like performance, right. This is slide I like. I've been using it for a while now. It's still true, right. So how many of you know of this moral machine study? You might have seen this example as a trolley coming down a railway track, right. Then do you go left or do you go right, kind of a question, right. You can actually make it richer. So there's this MIT Media Lab did this various kinds of things, right. So you are coming in the highway in a car, there is a barricade in front of you. You could run into the barricade and you will cause injuries to people traveling in the car with you, or you can swerve to avoid the barricade, but you will hit the pedestrians who are crossing the road, right. So which one do you prefer? Now there are a lot more complications. So does your preference change if you are riding alone in the car? Does your preference change if you have a baby in the car? Does your preference change if it's a baby crossing the road? Does your preference change if the guy is jaywalking? right? Just crossing because the light is red, even though the light is red, he is crossing the road, right? Old people, young people. So they asked these questions under various kinds of differences, right? So they wanted to understand how humans' behavior is, right? So most emphasis on sparing pedestrians, right? So the Japanese would rather drive into the divider than drive into the pedestrians, like Norway and Singapore. The least emphasis on sparing pedestrians comes from China, Estonia, and Taiwan. I'm pretty sure they didn't interview Indians here, right? So otherwise we would be up there right next to the Chinese. But there seems to be significant cultural difference. Likewise, most emphasis on sparing the young, right? Again, France and Greece were more likely to spare an young, while the least emphasis on sparing the young, right? Where Taiwan and China, South Korea, and Japan. Right? So China because there are too many of them, Japan because there are too few of them. Japan is only filled with old people, right? They don't have youngsters to avoid anyway, whatever, right? But the point is, when I say I want to build a human-like AI system, we don't even know what human-like means, right? If I'm building an autonomous car and I want it to say, okay, I want you to solve the moral machine problem, then I have to say like the Chinese, right? I want you to solve the moral machine problem like the Japanese, right? Or like the Europeans. I have to say something, right? I can't just say I want you to solve the moral machine problem like a human being. Anyway, so so long way to human-like performance, but we have to work with AI with care in the meanwhile, because AI is not like any other 2-year-old. It's like this 2-year-old, right? And so you have to be careful. Anyway, so summing up here, more than ever closer to functional AI. In fact, we see AI everywhere, but we have to take it with a pinch of salt. I would say again, because normally in another version of this presentation, I'll show you stories from the 1950s. Where people were talking about AI systems autonomously going to the moon and exploring and reproducing and all that. And the paper comes from 1950s, right? So story comes from 1950s. Right? They importantly affect many aspects of everyday life. And how you know that is true? Because lawyers and politicians are talking about AI, right? So you know that AI has arrived now, right? So, but for me, the biggest danger from AI is humans rushing to market before the technology is ready. Right? So we really need regulations for AI. We really need to think about applying AI responsibly, right? And when is it really our fault, right? So we have to really think about all of that. Okay, so I'll stop.